Hi class, today's lesson I'm going to talk about repeated measures or within subjects designs. And the simplest possible repeated measures or within subjects design is a one-way repeated measures or within subjects design. So think of this analysis like a paired t-test uh, analysis that you might have done in an introductory statistics course where the values you're comparing are both from the same sample. Remember, an independent sample t-test, your values you're comparing, is this mean different than this mean, are from two different groups. But imagine people provided both groups. Now you'll see something like a pre-test, post-test. I've got your score at time 1 and your score at time 2, but everybody provided both scores. That's a paired t-test would evaluate the difference between those. In an independent sample, it would mean like the males provided one score and the females provided a different score. So I have two separate groups, in essence, subgroups that I'm comparing. But then within subjects or repeated measures, and you'll see these names are used for both analysis. They're largely used interchangeably, though I use them more specifically to mean the same thing. If I'm doing a time series kinds of things, pre-test, post-test, I might call on a particular measure like depression or anxiety or some sort of measure of knowledge. Is your knowledge at time 2 greater than your knowledge at time 1? I've got the same knowledge test used at time 1 and time 2. I might call that a repeated measures analysis of variance. But sometimes I'm measuring things that are provided by the same subject but are not necessarily the exact same measure, in which case I might call it a within subjects design, sort of the way I kind of separate them. Though mathematically the analysis is the same, the case I'm looking at, for instance, I'm dealing with some public data I found on political attitudes, and participants were asked if they favored, for instance, in one case, were asked if they favor, oppose, or neither favor, oppose. They're on 5-point scales, and I've reverse coded these. So higher value means supportive rather than not supportive, which the original data was. But in this case, I'm asking the question, is the government responsible for paying for the health care of all Americans? In the next question, is the government supportive or should they be paying for free public colleges or universities or free pre-kindergarten programs? So imagine I'm a politician and I'm trying to figure out what my constituents think are the most important issues for them. And there are three that I'm thinking about making a major part of my platform, and I want to know kind of what my research says. Should I sort of lobby for more health care, more education, or more pre-K? Right, this is my data. So I want to know if the mean supportiveness of these are similar or different from each other. So since I have more than 2 levels, I can't just use a paired t-test. I can do all 3 possible pairwise comparisons, but that would be not controlling for my family-wise error rate that we talked about in earlier lessons. But I've got more than 2 levels, so I'm going to use, if I go to the general linear model, a repeated measures design is what SPSS calls this. So I have a factor, which is basically what is the measure, and here it's attitudes towards these different issues, and I could call it something like attitudes. And it has 3 different questions. So I'm going to put a 3 in here. And then I'm going to hit define. And I'm going to identify which 3 questions are these. So my first one, you kind of need to remember this because SPSS won't label these very carefully. I've got healthcare, I've got college, and I've got pre-K. So I've got lots of different options here. I'll probably want to plot these. Means, horizontal axis, add, error bars. I want to see the chart. I'd like to see the means for everything. So I'm going to display those means, and I'm going to compare these effects. And I can do a Bonferroni correction in this case, which will allow me to determine which means if there's a significant overall within subject's effect, I'll be able to determine whether or not I should even compare post hoc the criteria or the factors against each other. And let's say I can go ahead and get descriptive statistics and effect size here, etc. All right, so I've run this analysis and I can see my means. I've got a large sample, over 1,500 people that provide answers for all of these. The mean for healthcare is 4.56, 4.64, 4.18. These are, not hugely different from each other, but there are differences, obviously, as there always are, but are they significant or not? We'll jump down here to Mauchly's test of sphericity, which is a test. One of the assumptions of repeated measures within subject designs is that the variances of the differences between all possible combinations of these variables are basically equal. Is the difference between issue 1 and issue 2, if I computed the difference score and looked at its variance, and the issue between 1 and 3 and 2 and 3, are the variances similar or not? Well, most of the time they're not, especially if you have a large sample, but Mauchly's test of sphericity determines whether or not I've met this assumption or not. In this case, it appears I've not. I've got a significant value. If I'm less than 0.05, I'd say I'm not clearly meeting Mauchly's test of sphericity. So I'll need to think about that and adjust some issues or report some different stats associated with that. You'll see these epsilons, which are how much of a departure from sphericity is there. And you've got two corrections, Geiser-Greenhouse and Went-Felt corrections. Typically, the rule of thumb is if your value is greater than 0.75, or less than 0.75, use Geiser-Greenhouse's correction, which is a correction of your degrees of freedom to prevent the fact that you're increasingly likely to make a type 1 error. One would mean I'm not significantly different. So if these were both 1, this value would be it would be above 0.05. If it's greater than 0.75, I would look at the Went-Felt correction of 0.94. So since this values are above 0.75, I'll use this correction and I'll look down here and notice the degrees of freedom have changed from 2 if I assume sphericity, a minor adjustment to 1.8, but I am significant. There's some significant differences between these means. I don't know which mean yet is significantly different from which other mean, but I would report that we did not meet Mauchly's test of sphericity, and we used the Went-Felt correction, and I would report its value and its p-value and the modified degrees of freedom, 1.8 and 2966, okay? And we can also see that in this data, the overall effect size of 0.27. That means whatever the difference is here, they're not huge. I've got a large sample. I've explained basically 2.7% of the variability in these differences. So that is sort of the major things I would report. Then typically people look at, well, if I want to jump to the chart, I can see what this. Issue 1 was healthcare, issue 2 was college tuition, and issue 3 was pre-care. My public seems most interested or concerned about the tuition here, and to a slightly lesser degree healthcare, but then considerably less worried about pre-K. Perhaps not as many people in my sample have children that are eligible for pre-K or anticipating that, but that's not quite as big of an issue. But I can look up, because I requested it, the pairwise comparisons, and I can see once again, and consistent with this chart, that healthcare and college are not significantly different from each other using the Bonferroni correction, but healthcare is different from pre-K, and college is also different from PK. So these two means would be evaluated as roughly the same, and this one as the weaker. And I could report these difference values too and correct this chart. Once again, illustrating the effect size, I can fix my scale, which was from 1 to 5, and hit apply. This is what I'm getting. Not a lot of difference, but if I took this to the bank, I'd say all of these are kind of important. My constituents value them all. They strongly support these positions by and large, but if I had to favor one or the other, I would say I might argue or support these, but if I actually supported this, I'd have to persuade people that it's actually more important than they think it is for whatever reason and go from there. But this is a basic repeated measures analysis and the way I might work through it and define that factor. So next step, we're going to add some more factors in the next video.